Hi to the second video of this series of the development process of an application from backend to frontend. So in the previous video, I was basically making an introduction to the project, to the reason of these videos, and also I made a simple setup for what is going to be the project that I will be making. So I have the CMD folder, the DB folder, the internal folder, and the package folder. So now we're going to expand on that. First of all, in the design that I want, and I will be leaving this in comments, the design that I like to follow is that the main.go file only has code for this stuff. First, it reads from env variables. So I'll have an env file. That's something obvious. It will be it will then, with those env files with variables, it will start those services. For instance, whether it is a Postgres database, Redis database, I don't know, connecting with any other service, it will be done in the main.go file for me, because these are dependencies that if any fails, then the application can't start. And so it let's say it runs services that are critical for the application, which means if any of those isn't running, then the application can't power up, can't start. And then it creates the HTTP server. Let's leave it like that, and that will be all. And here I would like to add that this also includes migrations. Migrations also comes for me like a service that if it can't run successfully, then the application can start. And that's what I like to leave in this main.go file. Now, in the internal file, as I said in the previous video, I like to have these folders, but I will move the middleware folder into the HTTP folder. The HTTP folder has all the code regarding the HTTP transport layer, which is the transport layer. If we were talking about a 3-layer architecture, then this will be the first layer, the transport layer. And then I'll have middlewares. I'll also have handlers, and I also have the API itself. Now the API, it's the server. When I refer to an HTTP server, is not simply the HTTP server from the standard library, but I mean our own API server, which is a structure that we're going to create, which also takes care of initializing the dependencies. Now, that's something that I would like to mention. I am a big fan, or it's like, not only that, it's like, for me, it's pretty important the way in which I use the dependency injection in my projects. However, in Golang, I have seen some options. Some of them are with generated code, like the Google Wire package. However, I don't like that kind of stuff. I don't like generated code. I try to avoid it as much as possible. For instance, with gRPC, I mean, there's nothing I can't do about it. But here, with dependency injection, there is indeed something that I can do about it, and it's doing it manually, the dependency injection. It can be more verbose, yeah, but I like to maintain it something like that. So what I want to say is that our own API server struct will be the one that will be injecting the dependencies. That's basically it. And also, so here, yeah, so let's start with that. Here we're going to create, how to call this one, let's say api.go. This will be from the package API. We'll have a type struct type API server struct, and for now this will have an address let's leave it like address, and it will be a string, I think, and for now that will be all. Let's create a function to create this. Be new API server, and this will return an API server, and return API server, and for now it will only receive the address, which will be a string, and so this will be it for now. And also, let's talk about it. I also like to have a config folder right here, which is like, I don't know if it's a pattern, but it's something that I like to use for the configuration, for the environment variables, I mean. And I like to have it separated in a config file, config.go, yeah. Let's call it package config, and here will be config struct. And well, I'm thinking because I guess the address is part of the configuration. It doesn't need to be it doesn't need to be a separated attribute, because I will be sending here a config file, config. Let's leave it as a pointer. And why is this define config? Yeah, because I have to mention the package. No, yeah, there will be a problem. So I will change here the name to config. Let's say custom cc config. Yeah, let's leave it like that. Config. Oh, yeah, excuse me, I don't know what I'm doing here. Configuration. So let me, okay. So here I have the configuration struct. What I'm thinking is that I don't need this address anymore, because I could pass it through the config file. Well, I'll leave that for later. So what variables do we need in the config, in the .environment? What variables? I mean, we need the Postgres, but I will add that later. For now, only the address. So let's leave it like port 8081, localhost 8081. Yeah, okay. And I'll pass that through the configuration file. Config, so the config will be an address, which is a string for now, yeah. And here I have func new config, and this will return config, and it will return config, and the address will be, and here is the pattern that I like to use. I like to use a function which is private for this package, so it starts with a lower capital, how is it called in English? Minúscula, lowercase, yeah, lowercase, and mayúscula, how is it? in capital letter, yeah. In lowercase, because functions with beginning with a lowercase letter means that they are private for their package. So in this case, I only want to use this function that will be the writing in this file, which is get_emp. This gets an environment variable, that's all, which name is, or let's call it emp string, and which fall case, let's call it like that, is this. What means this is that it will try to read an environment variable with this name. If this function is for strings, environment variables, so the name is this one that it's passed right here, and in case that that environment variable is not in the environment variables of the application, then it will assign this one. However, oh yeah, that will be. So because I was thinking that I would like to handle the case in which I want that if the environmental variables is not, no, forget it. So let's leave it like it returns a string, and the process is always how is it? No, mb no, is it? It is, yeah, is it mb string? Yeah, I forgot how to read environment variables in Go. So how to read mb variables Golang. Let's take a look here. Always always get_emp. Yeah, that's it. Always get_emp. Yeah, I'm not getting help because I have this issue right here. So I will string, and now it will show me the helps here, which is get_emp, and it will get_emp for emb. Now this is, let me check because I'll get_emp. Yeah, I think that's the only one. Retrieve the value of the environment variable named by the key. It returns the value, which will be empty if the variable is not present. So we take care of that. So if, let's say, val it's equal to always get_emp, yeah, and I will here just in case. Then if val isn't different to an empty string, then we'll return that value. However, if it is indeed empty, then we'll return the false case, and that will be all. So here, yeah, I don't know where I did this. Get_emp for address with a false case of 8081, and that will be our config file. Now I receive here, I will create a function, a method to our API server, which will be used to run the server. So let's do this API server, that will be all. And this is the method that is called by the main file. So the main file will, first of all, which it will load the environment variables from the .env file, and for that I need a package, which I don't remember very well. Go.emp. I think that this is how it's called. Go.emp. Yeah, it's this one. So let's call go get. Now go.emp.load, and file names, then it will be .emp. does it return something? Yeah, this return an error. So if an error is returned, then if error is equal error different to nil, then I would like to log dot fatal, because if the environment variables weren't loaded, then there's no case in trying to start the application. So let's log the error, and that will be all. Now, if we did load the environment variables, then we are going to create the config file. We're going to do this by using the config.new config, and this requires nothing. Yeah, this should return. Yeah, this returns the config struct. So let's receive it in a config configuration in order to have a name different from the package. And that will be all. Once we get all the environment variables, here we should start services. For instance, if we have a database that will be have in the future, will be start all those services here, verify that they work. If any of those don't work, then it doesn't work, then we shut down. But if everything works fine, then we're going to create the API server. However, I like to include graceful shutdown in the application, and for this we have to do some tricks that I don't remember pretty well how they are done. So I will try to do them from memory, and then I will check out a previous project of mine to see how I did before. So I know that I have to create a go routine to start the server. Why is it? Why in a go routine? Because I need a go routine which starts the server and maintains the HTTP server listening, which is a blocking operation. But I want to do that in a separated go routine, because I want, let's say, the main go routine or another go routine to be listening to cancellation signals in the application. So which will be a control C, a cancellation signal, while once it listens to it, then it stops the HTTP server gracefully, and then the application closes gracefully with closing the database collections and any other connection that was opened. So that's why it's very important to have a separated go routine. And in this go routine, we'll start the new HTTP server. And here we're going to listen to cancel signals. And yeah, I think that's how I did it the previous time. And yeah, let me check just in case. CMD application main app. Yeah, let me just copy this code. So basically, this is what this returns the context which will receive a signal whenever a system call is called. In this case, the termination signal, the control C signal. And yeah, that will be that's basically what it does. Now then, server.run HTTP log print server. Yeah, I get it. Yeah, let me just copy this code and server running port config.port. I have it like port, like address. Let me change that. Yeah, let me change that. I prefer port, obviously. Because it's obvious that it will be local host. It won't be a remote address. And let's change this to port, and that's all. So server.run, but I need to create the server before. So let me create to create the server. So api.new new API server, configuration, yeah, config, this is configuration, server.run. I have it here. So what's the issue with server.run? It returns an error, obviously. Error. And couldn't start server. If error is different to nil or error is different to error server closed. Yeah. And then I also copy this code. That will make it easier. So as I said, this context that we got from this line right here basically is a context created that will retrieve the signal, the cancellation signal, and in the Golang application it will be received as a message in the context channel. In this case, in the DOM channel, I mean. And then I have to implement a shutdown method to the server, and the shutdown method should be the one that closes all connections. However, that doesn't sound right to me. I don't like that pretty much. Let me check what I added in the shutdown method in this previous project. HTTP API. Let me. So my shutdown was return HTTP. Yeah. Func is API server shutdown return is server. Obviously here I need a server, which will be an HTTP server. No, server. Too many returns, but what does this return? An error, so let's return the error, and that will be all. Now I have the server. Oh yeah, that's why I need to create the server outside the function, and that will be the graceful cancellation of the application. However, here there's something missing. No, I think everything is fine. Yeah. Let's remove this line. I think it's pretty obvious. And now continue with the API with our server. So for now, this only does HTTP server. This is a struct. So let's say is.server. It's equal to a new HTTP no name server on the left. Yeah. Server. So this receives an address, a handler, TLS, with timeout, shutdown, active listener group, context, where's the handler, the controller, handler. Yeah. So let's pass the address, which will be s.config.port, and we also need the handler. And for the handlers, I'll use sheetrouter because I liked it. It's like it's pretty close to a standard library, but it adds the stuff that I like to have additional. However, I don't like this gene or echo, etc., because I think those abstract pretty much the development process. So I like to maintain it pretty close to the standard library as possible, because I have full control of everything. So let's get the sheetrouter. version 5, and let's copy it. Go get she, and now she dot new mux, and that will return the drawer, and that will be it. And the handler will be that drawer, and here in the middle will happen the dependency injection. For now, let's create simply a health check. So first of all, we'll have to create, it's always good practice to maintain our APIs versions. So I'll do that right now. So I'll keep this as error. And here what I will do is to create a new router, which will show new mux. And this will be the one that I will be managing, that I will be injecting the endpoints to. And what I'll do here is mount to B1 this new router. So basically the handler of the application is the error handler, which is the main handler. However, I'm gonna mount some, let's say, subrouter, which will be mounted in the P1. Basically, it's only to indicate that it's the P1 version, the first version of that router, and that will be all. And for now here, let's create a router. Let's health check router dot get health, and this write, and let's write hello world, and that will be all. And let's add a header with the HTTP status okay, our header, yeah, this is in the function, it's right header, I think, right header, yeah, HTTP status okay, and that will be all. In the main.go file, start services gracefully shut down, couldn't start. So let's check if the application works. So go and run cmd api main.go. It looks like we have some errors. The path, let's try again. Some more errors, health, yeah, it seems like the server is supposedly running on port 8081. So let's check it. In this case, I will use the Thunder client that I have in GitHub. So let's in VS Code, I mean, let's use this one. In this case, is for health API. I didn't add this one. I should. Well, connection refused by the server. It seems like we have some errors. Health B1 hello world HTTP. Oh, I haven't started the server yet. That's is so here I have to return s.server.serve and listener. Net listener, so I forgot what I need to add there. So let's HTTP serve go it's listen and serve. Listen and serve, and that will be all. Let's check again. Can start listening missing port in address. Specify the TCP, HTTP port 80. Host. This requires the port, the address of local host. Let's start again. It seems like it's supposedly working right now. Let's check again with the request. And now our server is working perfectly. Now let's check the graceful shutdown. Perfect. The graceful shutdown is working also. And I wanted to check something more, but I kind of forgot. Localhost, hello world. Oh yeah, I wanted to add the course configuration. That's pretty easy. I will do it in this video and then I will end the video. So it's like C course. Go C course. Yeah, it's this one. Course. I'll go to the C GitHub Go. I think right here it's something like, first of all, I will use all the middlewares that they recommend. I mean, why not? So let's do it. But I have to add the middleware. Well, I'll do it later. And also I want the course. Yeah, let's add a timeout also, I think. 1 minute of timeout. If any request lasts more than a minute, then it ends. And I am looking for the course configuration. However, I can't find it. Yeah, it's here. Let's copy the basic course. A good stack. And yeah, everything is perfect. Course, dependency injection. This function is kind of getting so fluid for my taste. However, I'll take care of that later. I think that once I start with the dependency injection, maybe, or maybe this, I guess that this function can be this long. I mean, it's not that long. It can be like the configuration of the router, and then I will separate the dependency injection in a separate function. I think that's the approach that I will be taking. And now all what it's left to be done is to get the dependencies. Go C course and go get go C middleware. C middleware. Yeah, I shouldn't be using this middleware. Go model, dice por qué, please upgrade to the latest major version. Go see. Yeah, let's just do that. And let me check in the Go module. Go see. This one. And let me look for it manually. Go C middleware. Go C. Yeah, I think it's not. OCC could it be? Let me check this. Yeah, now it's working. And yeah, that will be. Let's check one more time that everything is working fine. And now we have some errors. All middlewares must be defined before the roots. That's completely fine. Let's change that. So I have to do it before mounting the router here. So I'll remove these ones. This is pretty obvious what it does. And basic course, yeah, I don't care. Let's leave this like this. I don't need this. And now let's simply call this router config. Yeah. And let's start once again. Server running. Let's check on my browser. Localhost 8081. Page not found. What could it be? Oh, obviously, I haven't added the route yet. Yeah, everything working fine. And now here we have these are the middlewares that I copy paste from the recommended approach in the She repository. And these ones basically log information about every incoming request. So here I have that. In fact, I did a get request from this port, which means this is the port in which my Edge browser is running right now, and that will be. And this is the response code. In this case, 200, everything okay. And now let's confirm the graceful shutdown. And it shutdowns gracefully. So I think for now we're pretty good. Right now, at this point, we can say that we have the server running, and this is like a pretty generic configuration for any REST API. In the next videos, I'll start with the specific endpoints for my project, so those will maybe be more interesting and useful, I think. However, this is a pretty good approach, so let's commit the changes. Git add git commit, and let's say server created, and let's push the changes. And that will be all for this video. Check you on the next video.